In nature, when we look at ions, we find that atoms tend to form the same basic ions almost all the time. There's some tricky rules with bigger atoms like the transition metals, but in this video, we're just going to talk about the most basic rule that dictates what ion an atom will happily form. The rule is that they want their outermost shell to be completely full. Now, for some atoms, that might mean that their outer shell ends up being totally empty. But in the end, if you consider the last shell that they have any electrons in, they want it to be at 8. Remember, our rule is saying that they can hold 2, 8, or 8, unless it's that small one, and then they want it to be at 2. This is sometimes called the octet rule, because octet is a nice word for 8. So let's take our atom oxygen. Oxygen has an atomic number of 8, an atomic mass of 16, and I'm going to do the Bohr-Rutherford diagram, but what I'm going to show you is that he likes to form a specific charge. So that's what we're going to try and figure out. So the number of protons is 8, and the number of neutrons is 16 minus 8, or 8. So I can make the nucleus of my Bohr-Rutherford diagram 8 and 8. And then I can start filling shells. And for the sake of what I'm showing you right now, I'm going to put in electrons at 8 as well. And at first I'm going to show you then the neutral atom, where the number of protons and electrons are the same. So that's him right there. Now I'm going to change colors here. Let's go red. So what is the easiest way for this atom to finish filling its outermost electron shell? So here's its outermost electron shell. It basically has two options. It could lose all of these electrons and lose all 6, or he could take on 2 new electrons. Taking 2 electrons is a lot easier than losing 6 electrons. So what this atom will do is he'll take 2 extra electrons, and instead of being neutral with 8 electrons, he'll move up to 10 electrons. What that means then is that instead of the charge on this atom being neutral, the charge on this atom will be -2. So when you find oxygen in nature, and he's part of a chemical bond or he's part of a formula, the most common thing you're going to find is that oxygen always has a -2 charge that is associated with filling out that outermost shell with those 2 missing electrons. Let's look at the opposite situation. Let's look at an atom now that instead of getting more electrons, will find it easier to get rid of the electrons that it has. Let's look at lithium. Lithium has an atomic number of 3 and an atomic mass of 6.9. We'll round that to 7. So the number of protons is 3. The number of neutrons is 7 minus 3, which is 4. So I have 3 protons in the center, 4 neutrons. And in that first shell, I have this, he's full with his 2 electrons. And then if I just make lithium neutral or normal, I just put in that 1 electron there to get up to 3 equals 3. Now, for this atom to get neutral, or to get a full outermost shell, he would have to add 1, 2, 3, 4, 5, 6, 7 different electrons. That's a lot of electrons for him to take from other atoms. Alternatively, if he wanted to go empty and then the inner shell would become full, what he could do is he could just kick out one of his electrons. If he did that, he would only have 2 electrons, and his charge would be +3 minus 2 for a charge of +1. So lithium tends to form a stable charge of +1. Some atoms, it's easier for them to get more electrons, and when they fill in those holes, they become negatives, and these atoms in general are called non-metals. and they exist on the left side of the periodic table. Alternatively, some atoms like to give away their electron to become stable. They are metals, and they're on the right side of the periodic table. As we explore the periodic table in more detail, we'll look at trends in the valence electrons of the periodic table, and we'll figure out what common ions things tend to form. And as a result, we'll see many patterns on the periodic table that show us why it was arranged the way that it is. So that's common ions.